Hello, this is Priya, your maths tutor, and once again, I welcome you all on my channel, Vidya Lee. So, students, in the last session, we have started exercise 8.3, question number 4, of which we have already completed the part 1 and 2. So, today we are going to start part 3rd of the question number 4th. Of the question number 4. So, let's get started. So, we have tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. And we need to prove that this will be equals to 1 plus secant theta into cosecant theta. So, let's solve the left hand side. Now, we have the tan and the cot in the left hand side. So, we know that tan theta is sin theta upon cos theta and cot is cos theta upon sin theta. So let's substitute the values. So we'll get sin theta upon cos theta divided by 1 minus cot theta, that is 1 minus cos theta upon sin theta, plus in the left right term we have cot theta, that is cos theta upon sin theta divided by 1 minus tan theta, that is 1 minus sin theta upon cos theta. Now we'll solve it, and in the denominator we'll take the LCM. So sin theta by cos theta into this cos theta will shift in the denominator as it is dividing. So 1 minus cos theta upon sin theta. We'll taking the LCM, we'll get sin theta as LCM and 1 upon 1 multiply LCM, that is sin theta. Cos theta upon sin theta multiplied by LCM is cos theta, right? Similarly, on the right term, we get cos theta upon sin theta into denominator. The LCM will be cos theta, and in the numerator, we'll have cos theta minus sin theta, right? Now, what we'll do? We will, in the denominator terms are dividing, so we'll multiply it by shifting it to the numerator. So, let's take the reciprocal of the term in the denominator. So, it will be sin theta upon sin theta minus cos theta plus cos theta upon this cos theta upon sin theta, and in the denominator will have cos theta minus sin theta, and this will shift to the numerator and it will become cos theta into cos theta, right? Now sin theta into sin theta is sin square theta, and in the denominator we have cos theta into sin theta minus cos theta plus cos theta into cos theta is cos square theta upon sin theta into cos theta minus sin theta, right? Now, let's again take the LCM. So, for the LCM, first of all, let's take the minus sign common. So, to make the two terms same, so it will become sin square theta upon cos theta into sin theta minus cos theta. While taking minus sign common, we'll get minus cos square theta upon sin theta into sin theta minus cos theta, right? Now let's take the LCM. So we'll get sin theta into cos theta into sin theta minus cos theta as the LCM, right? So taking this term, first term multiplied by LCM, we'll get sin square theta into sin theta, the sin cube theta. And on the right side, we'll get cos square theta into this cos theta, that is cos cube theta, right? Now, a cube minus b cube. A cube minus b cube is equals to a minus b into a square, yes, plus ab plus b square, where a is sin theta and b is cos theta. So let's apply the identity. So we'll get a minus b, that is sin theta minus cos theta, into a square plus b square plus a into b, that is sin theta into cos theta, right? And in the denominator we have sin theta into cos theta into sine theta minus cos theta. This sine theta minus cos theta and sine theta minus cos theta will cancel out each other. So now this sine square theta plus cos square theta is 1. So we'll get 1 plus sine theta cos theta in the numerator, and in the denominator we'll get sine theta into cos theta. Now we will break it. So 1 upon sine theta into cos theta plus sine theta cos theta upon sine theta cos theta. Now 1 upon sine is cosecant, and we can write it as 1 upon cos is secant, right? Sine theta cos theta and sine theta cos theta got cancelled. So we got 1 plus cosecant theta secant theta, which is equals to right hand side, right? So we got 1 plus cosecant theta into secant theta, which is equals to right hand side. Hence, proved. I hope it is clear to everyone. Although it's look very lengthy, the process is lengthy, but the question is not tough. So let's revise it again. So first of all, we have the tan theta. Tan theta is equals to sine theta upon cos theta, and cot theta is cos theta upon sine theta. So we have substituted the values. So we got sine theta upon cos theta upon 1 minus cos theta upon sine theta. Now taking the LCM of the denominator, we'll get sine theta minus cos theta upon sine theta. And here, similarly on the second term, we'll get in the denominator cos theta minus sine theta upon cos theta, right? Now, we have sine theta upon cos theta. This term is multiplying in the denominator when it was divided. So when we want to multiply this term, we'll take the reciprocal of it. So sine theta minus cos theta upon sine theta will become sine theta upon sine theta minus cos theta when we will multiply it, right? Similarly here, this term is dividing with this fraction. When we want to multiply it, we will take the reciprocal of it. So cos theta upon sine theta multiply cos theta upon cos theta minus sine theta. Now sine into sine is sine square, cos into cos is cos square. Now we have both the terms same, but the sine we need to take it out common, so we have to get the same term. So we'll take the sine minus 1 common from this one, and we got minus in between. Now taking the LCM again, we'll get sine theta into cos theta into sine theta minus cos theta. And in the numerator, we got sine square theta into sine theta, which is sine cube theta, minus cos square theta into cos theta, which is cos cube theta, right? Now we have the identity a cube minus b cube, which is equals to a minus b into a square plus ab plus b square. So we'll apply the identity. We'll get a minus b into a square plus b square plus ab. Now this sine theta minus cos theta and the sine theta minus cos theta will cancel out each other. And the sine square theta plus cos theta is 1 plus sine theta into cos theta. And in the denominator, we have sine theta into cos theta. Now we'll break it out. So 1 upon sine theta into cos theta plus sine theta cos theta upon sine theta into cos theta. Now 1 upon sine is cosecant and 1 upon cos is secant. Similarly here, sine theta upon sine theta will cancel out each other, and we got cosecant theta plus secant theta, which is plus 1. Sorry, cosecant theta into secant theta plus 1, which is equals to right hand side. Hence proved, right? Now let's start the part 4th. So in the 4th part, we have 1 plus secant theta upon secant theta. 1 plus secant theta upon secant theta equals to sine square theta upon 1 minus cos theta. Okay, let's solve it. So part 4th, we have 1 plus secant A upon secant A, and we need to prove it. sine square A upon 1 minus cos A, right? Let's start. So let's take the left hand side. Left hand side is 1 plus secant A upon secant A. Now in the right side, we can see that we want the terms in cos and sine. So we'll change the secant to cos. We'll get 1 plus secant theta is 1 upon cos theta. So secant A is 1 upon cos A, right? Now, let's take the LCM in the numerator. So we'll get cos A, and in the numerator we'll get 1 plus cos A, right? And in the denominator we have 1 upon cos A. Clear? Now, when will the two terms are dividing, when we want to multiply it, we'll take the reciprocal of the two terms. So it will be 1 upon cos A into cos A upon 1. This cos and cos will cancel out each other. So we're left with 1 plus cos A. But now, having a look at the right side, we want 1 minus cos A in the denominator, and in the numerator we want sine square A. So how can we get 1 minus sine A or cos A in the denominator? When we will multiply and divide the term by 1 minus cos A. So we'll multiply and divide by 1 minus cos A. Let's see what we'll get. We already have 1 plus cos A in the numerator. We have multiplied it with 1 minus cos A, and we have also divided it with 1 minus cos A. Now, A plus B into A minus B is A square minus B square upon 1 minus cos A. Now 1 square minus cos square, which is equal to sine square A upon 1 minus cos A. And this is what we want, right? So we got equals to right hand side. Hence proved. I hope it is clear to everyone. So what we have done first, we have the value secant in the left hand side. So we have converted the secant to cos, and we got 1 plus 1 upon cos A upon 1 upon cos A. So we have simplified the terms and we got 1 plus cos A. Now, as per the right hand side, we want 1 minus cos A in the denominator. So to get 1 minus cos A in the denominator, we have multiplied and divided the term by 1 minus cos A. So we got this part. Now A plus B into A minus B is A square minus B square. Now 1 minus sine square is cos, 1 minus cos square A is sine square A, which upon 1 minus cos A, which is equals to right hand side. Hence proved. I hope it is clear to everyone. Wonderful. Now, let's start the next part, the part 5th. So in the 5th part, we have cos A minus sine A plus 1 upon cos A plus sine A minus 1 is equals to cosecant A plus cot A. This is a part 5th, which is very important. And here we have to use this identity to solve this question. We have given it, we need to use this identity, but in the exam, you will not get this hint. You will be given just this statement, that is to prove left hand side is equals to right hand side. So let's start the question. Let's take the left hand side. So left hand side we have is cos A minus sine A plus 1 upon cos A plus sine A minus 1. Now, looking at the right side, we want the answer in cosecant and cot. How can we get cosecant and cot? When we have the 1 upon sine or cos upon sine, then we'll get cosecant and cos, cosecant and cot, right? We have cos and sine. So what we'll do? First of all, we will divide the term, the numerator and denominator by sine A. So let's divide the numerator and denominator by sine A. So we'll get cos A upon sine A minus sine A upon sine A plus 1 upon sine A for the numerator, And for the denominator also, we'll get cos A upon sin A plus sin A upon sin A minus 1 upon sin A. Now this sin and sin will get cancelled and this sin and sin will get cancelled. This cos upon sin is cot and this cos upon sin is cot. 1 upon sin is cosecant, 1 upon sin is cosecant. So we got a similar terms like cosecant and cot. So let's write it down. So we got cot A minus 1 plus cosecant A upon cot A plus 1 minus cosecant A, right? Now, we need to use this identity cosecant square A is equals to 1 plus cot square A. But we do not have the cosecant square A, but we have the 1. So we'll apply the value of 1 is equals to cosecant square A minus cot square A here, okay? So let's substitute. We have cosecant A plus cot A minus 1. So instead of minus 1, we will substitute cosecant square A minus cot square A. Cosecant square A minus cot square A upon, in the denominator we'll have cot A minus cosecant A plus 1. Why we have used it? Because we have given cosecant square A is equals to 1 plus cot square A, right? And from this, 1 is equals to cosecant square A minus cot square A, right? Now, if we look at these two, A plus B, okay, let's simplify it first of all. So this is A square minus B square, which can be written as A plus B into A minus B. Let's write it as A plus B into A minus B, right? And in the denominator we have cot A minus cosecant A plus 1. Now, from these two terms, we can take it out common. So we'll get cosecant A plus cot A will take common. So we'll get in the left side, and the left term we'll get 1 and in the right term we'll get minus term, that is cosecant A minus cot A. We'll keep it in bracket and in the denominator we have cot A minus cosecant A plus 1. Cot A minus cosecant A plus 1. Now, simplifying the right bracket, we'll get 1 minus cosecant A minus minus plus cot A divided cot A minus cosecant A plus 1. Both are the same terms, so we'll cancel out each other. So we're left with cosecant A plus cot A, which is equals to right hand side. Hence proved. I hope it is clear to everyone. Wonderful. So let's revise it once again. So we have cos A minus sin A plus 1 upon cos A plus sin A minus 1. First of all, we have divided both the numerator and denominator by sin A to get the terms like in the cosecant and cot. So we got cot A minus 1 plus cosecant A, cot A plus 1 minus cosecant A. Now, we need to use the identity cosecant square A is equals to 1 plus cot square A. So, instead of 1, we have substituted a value of 1 using that identity, which is cosecant square A minus cot square A. Now, this is again A square minus B square, so which is equals to A plus B into A minus B. Now we have the two terms. Out of the two terms, we can take out one term common, which is cosecant A plus cot A. So we have taken it out, and in the left term we got 1, and right side we got cosecant A minus cot A. And in denominator we have cot A minus cosecant A plus 1. We have written as it is. Now cancel out both the terms, which is same. So we are left with cosecant A plus cot A, which is equals to right hand side. Hence proved. I hope it is clear now. Wonderful. So till now we have completed till the part 5th, and the next video will start from the part 6. So for that, stay tuned. Bye-bye. Have a nice day.